Hi everyone, today we're looking at Unit 5, Lesson 2, the quadratic formula. So we're going to start by looking at a quadratic in standard form, and we're going to try to solve this quadratic. So we need to remember that when it's asking us to solve, it means to find values of x. So those values of x, we call them our roots, call them our zeros, x-intercepts, or solutions. All those words mean the same thing, but when you're asked to solve a quadratic, that is what you're looking for, your zeros. Okay, so if we look at this looks like it's a complex trinomial. So we should always first try to common factor. So if we look at this, is there anything we can common factor out of 3x squared, 4x, and 18? There's no common factor. So then we're going to look at trinomial factor. So this is complex, so we'll take a look and see if we can do decomposition. So I'm going to set up SPF. So I need two numbers that add to 14, and then two numbers that multiply to 3 times 18, which is negative 54 in this case. So multiply to a negative 54. So we'll take a look at our factor pairs of 54. So we'll have 1 times 54, 2 times 27, 3 times 18, no, 4, 5, 6, 6 times 9, and that should be all of our factors. So can any combination of those add to 4, and add to a positive 4 actually? So 6 and 9 is pretty close. It can add to 3, but I don't actually see a factor pair that would work. So there's no factors. So that means we can't factor this. Okay, it means we cannot factor this the way that we're used to factoring it. So when you cannot factor, there's two possible reasons why. Okay, the first reason is there's just no roots. There's no x-intercepts. We've seen quadratics that look like this. So there are no roots. And remember, roots are our zeros, our x-intercepts, our solutions. And that means we have a quadratic that's going to look something like this, right? Where it sits above our x-axis. Okay, it doesn't actually touch our x-axis. That's why there's no zeros. The other possibility is that our roots or our solutions are just decimals. So there could be roots, but the values are not factorable. Which means they are decimals. Because whenever we look at factor pairs, we're always looking for a whole number. So sometimes the two numbers that multiply together to work out in factoring might be a decimal, and we are not going to know all those possible decimal values. So we need some other formula to help us figure that out. So when a quadratic cannot be factored, there might be two solutions, and we need a different way to find those two solutions. So that's where we use our quadratic formula. So this quadratic formula is a new formula we're introducing, and it looks like quite a long formula. You'll always be given it, but I also do think from experience that if you use it enough, you're going to remember it too. So the quadratic formula is x equals, okay, and x represents our solutions or our x-intercepts when we're trying to solve a quadratic. So x represents our solutions, and it's x equals negative b plus or minus. We've seen this plus or minus before, where basically it helps us identify what two different solutions or two different roots are. So we'll look at that. Plus or minus the square root of b squared minus 4ac all over 2a. Okay, and those a, b, and c come right from our standard form. So we can only use the quadratic formula when a quadratic is in standard form. If it's not in standard form, we would first need to put it in standard form and then apply the quadratic formula. So let's give this a try with this same quadratic we were working with. So we have 3x squared plus 4x minus 18. So we're going to identify our a, our b, and our c, so we know where to plug it in. So a is 3, b is 4, and c, make sure you put the appropriate sign on all of your letters, is going to be a negative 18. So the quadratic formula just so we get used to writing it, is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so let's start plugging our values in, and then we're going to talk about how we're going to calculate this. So we have a negative b, so my b value is 4. So always helpful to write your negative and then put the value in brackets so we make sure that we're including the negative from the general equation. Under that, we have 4 squared minus 4 times my a value, which is 3, times my c value, which is negative 18. All of that is going to be over 2 times 3. Okay, so as we start to simplify this, we're going to simplify everything we can under the square root. So I'm going to write simplify under square root first. Okay, so we have a negative 4 plus or minus. And then if we have 4 squared, that's 16. And then we have a negative 4 times 3 times a negative 18. So be very careful with your multiplication of integers here. I have a negative and a negative, so I'm going to end up with a positive, and that equals 216. All over, and we can simplify our denominator and say that's 6. Okay, so from there, I'll continue to simplify. So we'll have negative 4 plus or minus the square root. 16 plus 216 is 232 over 6. Okay, so once we've simplified as much as we can, this is where we're going to split into our two equations like we've seen in the past. Okay, so I'm just going to come up here with this. So we're going to have x plus, oh sorry, not x plus, x equals minus 4 plus the square root of 2, oh, I wrote plus or minus, plus the square root of 232 over 6. And we're going to have x equals negative 4 minus the square root of 232 over 6. Okay, and then we're going to, and we'll write that this is an or situation, right, where you can have either value. Then we're just going to solve. So you should be able to punch all of this in your calculator to make sure you're getting the most accurate answer. So we'll have a negative 4 plus whatever the square root of 232 is divided by 6, and that will equal 1.87. And if we do negative 4 minus the square root of 232 over 6, we should get a negative 3.20. Okay, so those are going to represent our solutions, just like usually when we factor, but they're decimals this time. They're not easy fractions or just a whole number. Okay, so we're going to make a note that for now in general, we're going to say we're going to round to 2 decimal places. Okay, and if we were going to show our solutions on a graph, okay, we're just going to show what these solutions look like on a graph, remembering that our solutions are simply our x-intercepts. Right, we would have one solution at a negative 3.20, and we would have another solution at a positive 1.87. Our a value would tell you that this is a parabola that's opening up, so we would have some kind of parabola that looks like this. It's going to point up, okay, and it's going to have zeros at those locations. Let's look at a few more examples. Is if you get a positive number under your square root, right? So if I get a positive number under my square root, that tells me that I ended up with two solutions, right? So if I had a positive value under our square root, we got two solutions. So that little part under our square root is our discriminant, and that's what that note is saying. Okay, in our next example, we have 27x squared equals 18x minus 3. We want to make sure that we move everything to one side. So that we have the equation in standard form. So we're going to have 27x squared. We're going to subtract 18x. And we're going to add 3. Then we're going to identify A, B, and C. So A is 27, B is negative 18, and C is 3. When we use our quadratic formula, remember it's x equals, and then it's negative, and then in brackets we put whatever the value of B is. So in this case, B is a negative 18, so we'll have a negative 18. And then under our square root, we're going to have a negative 18 squared minus 4 times my A value times my C value, which is 3. All of that is going to be over 2 times A, which is 27. So we will simplify as much as we can. A negative 18 is a positive 18. And then we want to simplify what's under our bracket. So negative 18 squared is 324. And then 4 times 27 times 3 is also 324. Okay, and that will be over 2 times 27 is 54. So we'll have x equals 18 plus or minus, well, 324 minus 324 is going to equal 0. So you're going to have 18 plus or minus 0 here over 54. So usually we would split this into two equations, but if we plus or minus 0, it's both going to be 18 over 54 because it doesn't mean anything. So we'll make sure that we reduce. So x is equal to, we can reduce the numerator and the denominator by 18. So 18 divided by 18 is 1, and 54 divided by 18 is 3. So if we were to take a look at what this actually looks like on a graph, right, it's telling us that we only have this one solution, and that solution is our x-intercept, or our 0, and it's at 1/3. Our A value tells us this parabola is going to point up because it's positive. So we're going to have a parabola that looks something like this. So if you get the same value under your square root like we did, where there was 324 and 324, so we can get the same value under our square root sign. What happens is we then only have one solution. You can see that we ended up with one x value, which means we only have one x-intercept or one solution. Okay, so when that happens under your square root sign, that means we're only going to get one solution. Let's look at one more example. Okay, so we have everything on one side of the equation. We have A equals 2, B equals negative 8, and C equals 9. Pause the video for a minute and see if you can plug into the quadratic formula and then simplify as much as you can. Okay, so hopefully you could simplify at least to this point where you have 8 plus or minus negative 8 under 4 by plugging in our A, our B, and our C value. Well, you'll notice that under my square root now, we got a negative. Under that square root sign, this time we got a negative. If you try to punch that into your calculator, if you try to take the square root of 8, it won't let you do it. You're going to get an error message. So you can't square root a negative. So what does that mean? If I can't square root a negative, well, what's my answer? It means that this situation is not possible. Right? This quadratic that was given to us, it's not a possibility, which means there's no solutions. So we would just say x equals no solutions. And this is that situation where if we look at a parabola, it sits above our x-axis or sits below our x-axis. It never actually crosses it. So it would look, oops. If we were to rewrite this equation, which we're going to learn later in the unit, but if we were to rewrite this equation in vertex form, the vertex form of this same equation would be x minus 2 squared plus 1, okay? So we can see from that our vertex is 2, 1, and it opens up because my a value is positive. So when our vertex sits above the x-axis like this at 2, 1, then it never crosses our x-axis. There's no solutions, right? Solutions are just those x-intercepts, and sometimes quadratics don't have any x-intercepts. So that's what that means when you get a negative under your square root. Okay, so we've looked at 3 examples for using the quadratic formula. I just want to kind of summarize the 3 different situations we have and talk about that little under the square root sign. So we've looked at how do you know how many solutions you have in a quadratic, and we've done so by plugging a y in for, or sorry, plugging a 0 in for a y, and then solving for x. There's another way to tell how many solutions we have using part of our quadratic formula, and that part is called the discriminant. Okay, so our discriminant is the part under the square root sign. Okay, so it's just that b squared minus 4ac. And you'll see I circled it in some of our examples. So this first situation, which I'm going to flip back one on this page. So when the discriminant is greater than 0, or when it's positive, you should end up with 2 solutions, or x-intercepts, or zeros, or roots. Okay, the other 2 situations we saw were what happens if that piece under the square root is just equal to 0, which we saw up here, right? When our square root was equal to 0, that only resulted us having 1 solution, or x-intercept, or 0. The last situation we saw was what happens when that piece under the square root, or my discriminant, is negative, like we saw right here. Well, what happened in that case is we couldn't have a solution because you can't take the square root of a negative. Okay, so if we're trying to determine how many solutions does a quadratic have, we can just take a look at the discriminant, or that piece under the square root, and evaluate if it's positive, negative, or equal to 0. If we actually want to determine what those solutions are, we'll have to carry out the entire quadratic formula though. Okay, that is it for your note for today.